here. Okay, so this is how these would be used in a proof. These all here are the if statements. So it'd be if any of these, then this is the conclusion. So all of these things prove or conclude that lines would be parallel to each other. So we're looking at the different reasons. So starting out, alternate interior angles. So if you have a pair of lines with alternate interior angles, if the lines are parallel, what do we know about alternate interior? They are congruent. So alternate interior angles, if we know they are congruent, so this would be your statement. If alternate interior angles are congruent, then the lines are parallel. Now, rather than writing that whole sentence out, because it's kind of working in reverse, rather than saying if the lines are parallel, then alternate interior angles are congruent, when you flip a statement, when you flip the if and the then, it becomes a converse. So the reason that you can write in a proof is AIA, or alternate interior angle converse. But I do actually want to write, I'm not going to write it for all of these, but I will for this one just so you know what that statement actually means. So as a full sentence, this is what it would look like. If alternate interior angles, so if AIA is or are congruent, then lines are parallel, whichever lines you're trying to prove are parallel. So that's the full sentence, but you just have to write as the reason AIA converse. So you're saying since the angles are congruent, therefore the lines must be parallel. So that's our conclusion. So alternate exterior angles. If lines are parallel, what do we know about these? They're also congruent. So if alternate exterior angles are congruent, then the lines are parallel. So that would be AEA converse. Alternate exterior angle converse. Similar statement, you're just swapping out the interior for exterior, but this is what it would look like as a sentence. CA was corresponding angles. What do we know about those if the lines are parallel? So yeah, they're either congruent or supplementary. So we have corresponding, and then we have, this is consecutive interior. The corresponding, these are the ones that are congruent. Consecutive interior are the supplementary ones. So for corresponding, we would have CA, corresponding angles, converse. So if corresponding angles are congruent, we know lines are parallel. And then for consecutive interior, if we know these are supplementary, then we can say the lines are parallel, and that would be CIA, converse. And then we have two of these ones you just would have to write out as a sentence for the reason if you used them in a proof, and we will have proofs that use them. But the first one says if you know two lines are perpendicular to the same line, then those two lines must be parallel. So again, this is still your conclusion. So just to picture this, so say you have two lines that are perpendicular to the same line. So this is what that could look like. So if you know that these two lines are both perpendicular to this purple line that I drew, if you know they're both perpendicular to that same line, you know those two lines must be parallel to each other. And then as the reason you would use in a proof, it would basically just be that statement. So I'm gonna, there's not a ton of room on that line here. So it'd be if two lines are perpendicular to the same line, then the lines are parallel. Okay, there's not a short way to write that. You would just have to write it out. And like I said, we will go through proofs that use that. But that is a conclusion you can make. And the next one is similar. It says if two lines are parallel to the same line, then we know those two lines are also parallel to each other. So what that would look like is, say you have two lines and then you have a third line that both lines are parallel to, then you really know all three lines are parallel, but the two lines you started with must be parallel to each other if they're both parallel to that purple line that I drew up here. So that would also be written out as a sentence. If two lines are parallel to the same line, then the lines are parallel. Okay, but even having that understanding that between today and really on Monday, when we're going through two-column proofs more formally, your goal is you are proving lines are parallel to each other. So that's not what you're given. We have been given in problems so far that lines are parallel, so now we're trying to prove that they are using this information. So this is, or really the practice today is to kind of get you set up for recognizing these pairs of angles. So if we look at the first set of examples, it says, given the following information, determine which lines, if any. So it could be that there are no lines that are parallel. So determine which lines, if any, are parallel, and then state the reason that justifies your answer. The reason would be one of these. Okay, so when I look at this figure, notice you have lines A and B, and then L and M. So number one is saying if we know angle 3 is congruent to angle 7. So if you look at the picture, here's angle 3, here's angle 7. So if we know these two angles are congruent to each other, saying which two lines, if any, could we conclude are parallel? Any thoughts? If angles 3 and 7 are congruent, which two lines could you say are parallel? So think about, our 3 and 7, are they any of these pairs of angles up here? They would be alternate interior for which two lines? A and B. So you could flip your paper to see that, but they are inside of A and B, and then they're on either side of L. So they're alternate interior angles for A and B. So our conclusion would be, and I'm going to use that notation if you have lines that are parallel. I could say A is parallel to B. Remember, that's the symbol or the notation for parallel lines. A is parallel to B. And then I have to state the reasons. That would be by, since they're alternate interior angles, that would be my alternate interior angle converse, saying if those angles are congruent, then the lines are parallel. So by A, IA converse. All right, so that's what you're looking at for these ones. If we look at number 2, 9 and 11. So 9 and 11, first identify, are these a special pair of angles? They are corresponding angles for which two lines? For A and B again. So I could say A is parallel to B by, and since they're corresponding angles, it would be the corresponding angle converse by CA converse. Okay, so I would like you to look at 3, 4, 5, and 6. Do you have a question, Spencer? Converse is switching the statement around. So before we were saying if the lines are parallel, then we know these angles are congruent. The converse is when you switch it. So if you say if the angles are congruent, then the lines are parallel. So you're switching like the beginning statement and the conclusion. So rather than having to write that sentence out every single time, you can just call it the converse. Yeah. Good question. Okay, so 3, 4, 5, and 6. I want you to take a couple minutes, look at those. Say, if you can conclude two lines are parallel, which ones, and then why? There is one of those 4 that does not conclude lines are parallel. So I'll give you that. There is one that doesn't say either pair of lines is parallel. Take a look at these. We will go through them. I just want to give you a chance to look at them first.
So like if I'm looking at these angles are all interior, they're all inside these 2 lines, and these angles are all outside. And then these angles are all inside, and these angles are all outside. So interiors make their between the 2 lines, and exterior. Well, it depends on which pair lines you're looking at. But you're looking at these pairs. If I look at angle 2 and angle 16, you're saying, are they any of these pairs of angles? So what I notice is they're both, if for these 2 lines, they're both outside of these 2 lines. They're exterior angles for these 2 lines. And then they're on opposite sides of this line. So these are alternate exterior angles for lines. So this would come. Keep it on there. These are alternate exterior. And it's alternate exterior. So you would have to then L is congruent. Sorry, L is parallel because of exterior angle. So that's what you're looking at. Well, exactly what I just said. What you look up here, so you say which 2 lines are parallel, by, and then which reason.
Okay, let's go through these. I know some of you might still be looking at them. That's okay. Anyone want to share what they had for 3? So if angles 2 and 16 are congruent. Spencer? Yes, so it should be L is parallel to M, because for L and M, these are alternate exterior angles. So by alternate exterior angle converse. Oops. Little short. All right, what about 4? If angle 5, the measure of angle 5 and the measure of angle 12 add to be 180. So if angles 5 and 12 add to be 180. Guys, I need your attention up here, please. Which 2 lines could be parallel, if any, and then why? Anyone have number 4? Quinn? Yep, so L and M, these would be consecutive interior angles. So L is congruent to M. These are consecutive interior. If they are supplementary, they add to 180. The lines are parallel. 5, if angles, the measure of angle 2 and 3, if those add to 180. Yep, which 2 lines would be parallel? A and B, yep.
I was going to say A and B. I can't say.
All right, then what about 13 and 11, if 13 and 11 are congruent? What type of angles are 13 and 11? Vertical angles. Do vertical angles prove lines are parallel? No. So these are congruent. I mean, that's true, vertical angles, but it does not have to prove that either pair of lines is parallel. Vertical angles do not prove that. Okay, then we have, guys, I need your attention, please. We have what's called the parallel postulate. So it says if given a line and a point not on the line, so if we have a line and then some point that is not on that line, the parallel postulate says there exists exactly one line through that point that is parallel to the given line. So hopefully that makes sense, that there's only one line that could go through this point that would be parallel to the other one. Any other line that would go through that point would not be parallel. So that's something that we may use within our proofs as well, the parallel postulate. But getting to the remaining examples. So this is finding the value of a variable that would make 2 lines parallel to each other. And again, it's using these relationships, these angle relationships up here. You guys, I should not have to talk over anybody, and I should not have to remind you multiple times in one class period that I shouldn't have to talk over anybody. I get that some of you might understand this, some of you may not. So it's disrespectful to me, but also to your classmates. Not all of you have the same understanding of what's going on in here. Okay. Thank you. So you're finding X to make the pair of lines parallel. Again, using these relationships, and then identifying the reason you use, which again is still from up here. So if I look at example 7, I'm trying to prove that L is parallel to M, or I want to make these two lines parallel. So I look at the angles that are labeled for me. I have 5x minus 5 and 6x minus 20. What would this angle pair be? Alternate exterior angles. So my angles are alternate exterior angles. And in order for these lines to be parallel, these angles must be congruent to each other. So I have to find the value of x that makes them congruent. To do that, I can set them equal to each other and solve for x. I'm saying that they must be equal for these two lines to be parallel. So I would say 5x minus 5 must equal 6x minus 20, and I would solve for x. Just to keep x positive, I'm going to subtract 5x from both sides. So negative 5 is equal to 1x, or just x, minus 20. And then if I add 20, I get positive 15 is equal to x. So x would equal 15. That value of x makes alternate exterior angles congruent, which makes the lines parallel. Okay, questions there? Okay, so then if we look at 8, again, here's L, here's M. I want them to be parallel. What's the relationship between these two angles? And for lines to be parallel, alternate interior angles must be what? Congruent. So I have to set these equal to each other in order to find the x value that makes them congruent. So this angle I know is 90. So I know 3x plus 15 must equal 90. And then solve for x. Subtract 15. So 3x would equal 75. Divide by 3. And so x would equal 25. That is the x value that would make them parallel. Questions there? Okay. I want to look at one more with you. I want to look at 11. So again, you're trying to prove L and M are parallel. What would the angle pair do we have in number 11? Consecutive interior angles, which if lines are parallel, they must be what? Supplementary. So what equation would I set up to find x here? Yes, these two together must equal 180. 2x plus 6 plus the other angle is 130 must equal 180. Okay, and then I'm going to combine these. So I have 2x plus 136 equals 180. Subtract 136. So 2x would equal and then divide by 2. So x should equal 22. All right, I'd like you to look at 10, 12, and 13. So name the pair of angles you have, what should the relationship be, and find the value of x. I'll take it. I have it on the desk.
Sure.
Yes. I please have the sheets. Thank you. You're welcome.
So this is this here. And what that means here is.
Oh, it's according to where they go.
Exterior corresponding or. Well, if you look at it, so if this is L and M, this one is inside, this one is outside. So they're not both interior or exterior.
What?
These two are corresponding.
Yeah, my boss said, welcome to the club.
Well, you're trying to prove L and M, the directions for these is you're trying to.
I'm a chair in this class, I want to be taller. No, that was grounded. I threw a pencil in the thing and spit. Well, you're talking to a chair that's.
Either way, you can go past these people in each other. They still get stuck because who's in focus. It is correct.
They're not alternate. That would be like. So this is exterior, but this is inside of those lines. So these are actually corresponding. They should still be congruent, because I'm looking at the unit set of each other. They should be congruent, so then I can show that. It's not bright white, I mean, it looks good, but it's like this. You're still using. Well, and you're right. It's like.
How much square was the other one?
Oh yeah, we also have tests, so.
Yeah, we want quieter than.
We can get on now.
So, should we want to that is right here? And this one's right here.
What?
You know, to, these are.
Yeah, it's not coming from here, you said now.
Well, they're in.
Janet, and you stupid.
They are. So we have.
Yes.
We know, and then alternate interior. These two are alternate interiors. Do you guys realize they're outside? But they're on the opposite so it's not alternate interior. We know it's not. We know it's not alternate interior. Yeah. So to add these two together.
Those are not. They're yeah. And then I expect like. It's like. It's just 40. Have them should be supplementary, but you have them to go through. You have.
Well, how much is like this? Yeah, that's right. Yeah. Yeah. What? I wasn't thinking because she was like that. I was just acting like she was. But I know she's like
Yeah.
Yeah, I'll take that.
Okay. No.
No, I don't know it. I don't know if you know what. You don't know it.
Okay, you should have, everybody should have the assignment. You still have some time to work on it, continue working on it. 1 through 4 are like the first examples we did. The picture just looks different. So work on this. Let me know if you have questions while you're still in here. And then since you are not here tomorrow, we are checking this Monday. I'd still do it tonight just so you don't forget about it.